Hello and welcome. Enrichment and integration. But today we don't have further maths. I put an integral up there, which of course is quite tough to do, but it involves just nothing but ordinary straight maths. Should be accessible to anybody who just doesn't know anything about hyperbolic functions, arctans, and this kind of integral little t substitutions. So pause the video if you want to have a go. It looks hard, but once you see how to start it, in fact, this is not hard at all. Okay, if you've done this integral, I think the answer, I think was log 2, but I can't remember at the front. It's probably either a half log 2 or a quarter log 2 or something like that. If you've got this number, well done. If not, this is how this needs to be done. Let's write it again. So not to infinity, e to the 8x minus e to the 2x over e to the 8x plus 3 bracket e to the 2x plus 3 dx. Okay. What should be going through our heads when we're looking at something like this? Well, certainly looking at these brackets, it reminds me of partial fractions. And partial fractions, nothing but just looking at perhaps the end result of addition of algebraic fractions. So perhaps it's worth a try to say, look, maybe we started as something which was out of e to the 8x plus 3 and was added or subtracted. When I say add, I mean adding or subtracting e to the 2x plus 3. And this, of course, when we add them, this is the lowest common multiple, is my denominator. And then, of course, if I put this on the top and that across, maybe I can get something which looks like that. I certainly will have the e to the 8x sum on the top, definitely this one as well. I just need the 3's to cancel, so definitely I will need the plus and a minus between them, and any number on the top, for example a 2 and a 2, will get rid of the 3's because of course that's a 6, that's a 6. So long as one of them is a minus, it will work. Okay. So what kind of numbers we need in there? It's not that difficult to actually see. In order to get a positive e to the 8x, this must be positive 1. So in order to get e to the 8x plus 3. But then, of course, I need to cancel that afterwards. I need, of course, to have a minus e to the 2x. So if I need to have a minus 1 up here. So when I do this now times this denominator, I'm going to get e to the minus 2x, but more importantly, I will also cancel the negative with the negative 3. I will cancel the positive 3 that gets produced from this fraction. So this is actually done. It's partial fractions, but very, very different. I mean, who would have thought perhaps starting with something like this and perhaps putting them to a single fraction? Okay, it's a little bit annoying because I have it back to front. So can I just leave them as they are, or shall I just leave them? It's just bad karma. Let's leave them. Okay, let's hope that this doesn't bother us. The next thing that we need to look at is let me put this minus at the front here. Okay, the next thing to notice is the structure of either of those two fractions is exactly the same. It hardly matters if this was an 8, a 2, a 17, a 37, a 3. It doesn't really matter. If we can do this, we can do the other one just as good. So what we're going to do, shall I do it as a definite integral? Probably I'll do it indefinite, so I will ignore the limits. So let's do, and I will ignore this minus as well in there. So I'm going to look at e to the 8x plus 3 dx and think about how can I integrate this particular quantity. It's actually this, it can be done a couple of different ways. We are on enrichment at the moment. It's a 5-star question. I'm going to manipulate it as follows, and you will see in a minute why I'm doing what I'm doing. I'm going to multiply top and bottom by e to the minus 8x. This, of course, will become a 1, and then I have 3e to the minus 8x, and you should be able to see why I've done it. This because, of course, I created bottom differentiates to top. I just need to sort out the number here. This will differentiate to negative 24, so let's stick a negative 24 at the front and balance it accordingly. Okay, so now this is perfect. So the answer to that is minus 1 over 24, the number at the front, the log of this quantity. It doesn't need mods because that's always positive. So this is done, plus C. And the other one is exactly the same. I wish I had actually put like a K or an A there and leave it in general form, because now I cannot think how to change this number and what it will happen in there. So the time it takes me to think of a shortcut, it probably will be just as quick. It's only a couple of lines to actually do it from scratch. So it's exactly the same, identical steps. So we're having to multiply top and bottom by e to the minus 2x. This will become, I beg your pardon, a 1 times this by e to the minus 2x plus 3 e to the minus 2x dx. Bottom differentiation to top, but I need a negative 6 this time, so minus a 6 at the front to balance it. And of course now the answer is minus a 6th, the log of this denominator. So the integration is finished. So it's just an evaluation and a tidy. That's all there is, I think, on this integral. I cannot see anything else which might be complicated. A little bit careful with this minus in there. So this now, which one is that? That is this quantity. So when I'm writing it now and I'm evaluating, so I'm going to put my limits not to infinity, this answer that I got in there is in fact positive. So it's going to be plus 1 over 24. I wrote the plus explicitly to remind me that this I was actually a minus, but the minus there swapped it. The log of 1 plus 3e to the minus 8x. And then I got minus, when I'm adding this quantity, minus a 6th, the log of 1 plus 3e to the minus 2x. Close brackets, not to infinity. And the time it takes me perhaps to make some space on the board, some of us might be good enough to actually come up with the answer and check if that was a half or a quarter log to the final answer. I got the workings, I've done this integral a couple of days ago, and I don't quite remember what the answer will be, but I know it was something like that. And I've got the logs, of course, there. So let's have a think. What happens when we're putting infinity? I'm not going to use formal methods with limits and everything else. I'm going to do very hand wavy, very sloppy. I'm going to say, okay, if I put x is equal to infinity in there, e to the negative infinity is 0. So this exponential will die, take away also the 3. So that's going to be the log of 1, which is 0. But let's write it for completeness. Quarter log 1, and let's cross it out, minus. Same thing with this one. When we're putting infinity, e to the minus infinity is 0 times 3 is still 0, so it's minus a 6th, the log of 1, which again is 0. And then we're evaluating at 0. So when we're putting 0 in there, we're going to get 1 over 24. The log e to the 0 is 1, 3, 4. The log of 4, which can become, of course, log 2. And then we got a minus 1/6. Log 0 again in there, it hardly matters, e to the 0 is 1, so another log 4. And this will now give us, first of all, I'm going to do two things at once. I'm going to change the log 4s into log 2s and also remove this bracket. So it's going to be 1/3 log 2, so 2 squared, bring it to the front, it becomes a third log 2 positive, and then I go minus 1/12 log 2, and the question now is what's the third take away, third take away 12th, 4/12 take away 12th is 3/12, so that's a quarter, and the answer, of course, that we require there is 1/4 log 2, which is what I've just written there originally. So it was as expected, and I hope you followed this particular integral. If you look at it on the board now, I mean, obviously I took away the workings for integrating these quantities. It's actually not a lot of work to do. Quite ingenious in the sense, see what's the first step, which is the partial fractions, and then think about how we're going to integrate something which looks like that, which again, it requires a little trick, but once these two, that's the two main obstacles of the integral, we're done. I hope you enjoyed it. Who's laughing now?